Hi there, this is the first of the video tutorials to go with the digital soil mineralogy with our course. The idea behind these videos is to just provide an alternative way of learning for those that prefer to go through our code in this way. What the videos involve is simply going through all of the code that's in the material for the course online, just in video format, and I'll have time to elaborate on a few things to kind of unpick what the code is doing, and hopefully make it a bit easier to understand. In this first tutorial, what we're going to do is just simply load X-ray powder diffraction data into R via a couple of approaches. And this will mainly use functions from a package called powder, in addition to just basic functions that are actually pre-installed with R. So the first thing to do is load powder into your session. So that's done by running library powder. So I'm just highlighting it and pressing Control and Return to run that. And that will load the powder package along with all of the functions for analysis of X-ray powder diffraction data. So within powder, when you installed it, what you get in addition to the package functions are some example data files, and we're going to use these to look at how to load data into R. So the first example, we've got XY files that are stored in the package directory, and I created these using a little piece of software called powdll, and the details for that are in the course documentation, and it's really useful for converting a whole range of proprietary file types into XY format. So what this line of code is doing is just extracting the paths of these example data. So I'll just run that again by pressing Control and Return, and you can see that it just extracts the path for that file. So we need the full path in this case, and once we've got the path, which is now called file in our global environment, we can then apply a function called read xy to that path, and we create some data in the environment called xy1. Now, if we summarize xy1 using summary, using this line here, what we see is this summary shows how xy1 has got two variables, tth and counts. And this is 2 theta and count intensities that all X-ray powder diffraction data is comprised of, and it will be in this format throughout this tutorial. And if we look at the class of it as well, you can see that it's got a couple of classes. It's firstly an XY object, and it's also a data frame. So that means it's a little bit of a hybrid. And if we look at the methods of XY objects, you can see that there are a few different functions or methods that are associated with these XY files. And they are align XY, interpolate, and plot. And we'll come on to those a bit later. If you did the same thing, methods for a data frame instead, you'll see that there's loads of different methods for data frames as well in R. And that just means R recognizes various functions when when these kind of objects are passed to them. So that's how to load an XY file. We can also just have a quick look at it up here in the environment. If you just click on the data frame, it will load in just a regular tabular form. Now, similarly, you can actually load various proprietary file types straight into R without using powdll to convert them first. And likewise, what powder comes pre-installed with is a few different raw files, which are usually associated with Brooker. diffractometers. So here I'm just going to extract the path of one of these example raw files, and then instead of using read XY to get this file into R, I'm going to use extract XY. And if you want more information on any of these functions, so if I want to find out what extract XY does, I can just run $extract XY, and in the help tab you'll see some information about what this function is and where it comes from. You can see it comes from the PowDar package in this case, and the arguments it accepts, and some examples. So any function that is used in these tutorials will have help associated with it. And you can tell what a function is because it's got parentheses following the name of the function. So summary is another function, for example. Okay, so if we create xy2 using extract xy, you see that you get a little message saying that it's detected a raw file and loaded it using the function that actually does the work behind the scenes, called read xy data. So now we have xy2, which is identical to xy1. We've just loaded it in a different way. So if we do summary and a class, we get the same information as before. Now that's just for loading one diffraction file into R, but more likely than not, you're going to want to load a number of files at once. And this can easily be achieved in R again. So in this case, what we're going to do is use a slightly different function to extract the file names of all of the examples that are included with PowDar. So if I just run this, you can see that we got 5 different paths of all different examples of XY files. So you could just change this to the directory containing all of your XY files. Doesn't matter how many there are in there. Just make sure that the only files in there are your XY files. Now, if we create this paths1 string and then use read XY again, using the paths1 string to create XY list 1, what we end up with, if we just check the class, is something now called a multi-XY object, and it's also a list. So in the top right here, you'll see that it's a list, and if you hover over, you'll see that it's multi-XY. So it's just, as the name suggests, a list of 5 different objects, and each object within this list is actually an XY object or a data frame like we had before. So you can check the class of those just by using this little line of code. So we've got 5 different objects within the list that are each an XY object and a data frame. And if we want to extract information about a certain item within this list, what we can do is use the $ symbol and the name of the item in the list that we want information on in order to, for example, get the summary of it. Alternatively, you could access the same piece of data using a slightly different approach where you actually use the index. So we'll put 2 square parentheses and a 1 to extract information on the same piece of data. So there's 2 different approaches you can use for extracting data. And likewise, above, when we looked at the methods for XY objects, there are methods for multi-XY objects, and these are align XY, interpolate, multi-XY to df, and plot. And again, these will be introduced later on in the course. Now, similarly, we can use the same principles to load multiple proprietary files. So if we create another string of files called paths2, and send those paths to extract XY instead of read XY, we see we've got the raw files being detected and then loaded into XY list 2. And just like XY list 1, it's a multi-XY object or a list. And what we end up with is equal or identical to the data in XY list 1. We've just loaded it in a different way. So that's just a quick line of code to show that they are the same. So that's how to load just basic diffraction data into R and to create these XY objects and multi-XY objects that are like the foundation of the rest of the analysis that we'll be doing. And in the next video, we'll look at how to create some basic plots of these data now that they're loaded into R.